All right, good evening, guys. All right, welcome to physics. And sorry, there was a change in topic, or there's a change in topic rather. We ought to be looking at electricity, but I've not been able to uh, put uh, put the materials together for the class. All right, so that was why I switched into wave motion. Wave motion. We are not new to it. All right, it's not a new topic to us. It's not a strange topic to us either. All right, wave motion, wave motion. I'm not going to be going into deep analysis into wave and all that because I think we have secondary school knowledge. Like I said, our main focus is to prepare us for the exams ahead. All right, we know that wave is a disturbance, right? That travels through a medium. Okay, it's a disturbance first of all. It's an offset. Is a disturbance. It travels through a medium, right? And it transfers energy from one point to the other without causing a permanent displacement, a permanent damage of the medium itself. All right. Waves travel through mediums, all right, through a medium, a body. All right. They need some waves needs a body for them to be transmitted, for them to carry out their functions. Why some don't actually need a medium or a material body. Those are the kind of waves we call electromagnetic waves. Why those that require a medium, they are called mechanical waves. And one of the aspect of waves we are going to be dealing with much in this class, because I think it's a long journey, a long ride, a long ride. One of the waves we're going to be dealing with is sound waves. Yes, sound waves, because sound waves cover a whole lot of topics and areas in physics. Sound waves, light waves, sound waves, light waves, sound waves, and light waves. All right. So introduction. Then I've done a bit of introduction on waves. Then we're looking at still introduction properties of wave, got a wavelength. Okay, a wavelength, the frequency, the wavelength of a wave, uh, the distance traveled by a wave, right, measured in meters and represented as lambda. We are not strange to that. Then amplitude is the maximum displacement of a wave from its mean position or rest position. Amplitude. If you've done simple harmonic motion, you also make use of that term called amplitude. Then look at period. Okay, the number of oscillations covered, the number of oscillations or cycles covered in 1 second. That's the period of the wave. Then we have the wave velocity. Okay, wave velocity like a normal velocity, which is the speed traveled by a wave, the product of the frequency and the wavelength. You have your wave velocity. All right. With that as a brief introduction, let's quickly go to transverse waves. All right, transverse waves. Okay, waves occur frequently in nature. The most obvious examples are waves in water waves, right? On a dam, in the ocean, or on a bucket, all right? We are interested in the properties that waves have, all right? All waves have the same properties, okay? All waves have the same properties. But as we go on, we're going to begin to see some slight changes in that statement when we delve into electromagnetic waves. Yes, electromagnetic waves and all that. We're not going to see that some properties do not hold for some category of waves. Okay. Now, transverse waves. We have transverse waves and we have longitudinal waves. One of the waves, the direction is perpendicular to the vibration of the medium, while the other, the direction is parallel to the direction of the medium. We're going to see all that. So this is just like an introduction to waves, properties of waves, types of waves, mechanical waves, electromagnetic waves, longitudinal waves, transverse waves, and all that. Okay, quickly, what is a transverse wave? A transverse wave. Okay, look at a transverse wave is a wave where the movement of the particles of the medium is perpendicular. And I told you when I was talking about a transverse wave and a longitudinal wave. A transverse wave is a wave in which the direction of the wave is perpendicular to the direction of the propagation of the wave. All right, the direction of the wave, okay, is perpendicular to the uh, a medium of the wave. It's a wave. A transverse wave is a wave in which the direction of the wave is perpendicular. Perpendicular, we all know that simply means at right angles. That means the direction of the wave is at right angles to the wave. And if you see the diagram of a transverse wave quickly, we see that when the diagram is drawn, you see that when the structure of the diagram is sinusoidal, like a sine graph. Those of us that did mathematics, sine graph, sinusoidal in nature. We'll see the diagram shortly. Sinusoidal meaning that the wave has crests. The upward movements, the upward regions are called the crests. I think why the lower regions are called the troughs. Yes. So if we check, you see that the direction of the wave is perpendicular, is at 90 degrees to the vibration of the medium. The medium. The direction of the wave is perpendicular to the direction of the medium. And also note something in this slide. We see that we said a pulse is a single disturbance that travels through a medium. A wave is a periodic continuous disturbance. Note that, please. One of the questions Jamb likely ask. All right, what's the difference between a pulse and a wave? A pulse is just a single disturbance, a one-time disturbance, a one-moment disturbance, a single disturbance. All right, that travels through a medium. While a wave is a periodic sinusoidal in nature. It's a periodic or a continuous disturbance that consists of a succession of pulses. When you have succession of pulses, you have a wave. If you haven't been to hospital, I think where they use that device to read the heartbeat or the heart rate of a person that has been admitted, and you see something like a wave. All those things are pulses. When you have a succession of pulses, you have a wave.